Hey everyone, we're back here at our favorite ditch fun fly ever, the Birmingham Fun Fly, and I'm here with my two good friends, Matt and Amy Botos. How's it going?
It's going great.
It's awesome.
Good, good, good. So we're here at the lovely cow pasture where people just fly as low as they can in the ditch and whatnot. And as we promised this month, we're bringing to you quick tips number 4, which is the Synergy E6 and E7. So Matt, you did the miniature stuff for a while, and then you switched to Synergy. Now you're the head honcho there. So how did that all come about?
Well, the owner of Synergy died in a tragic car accident. After that, it was kind of in turmoil where nobody knew what was going to happen, and I basically just contacted a machine shop and said, "Hey, do you want to take on this project with me?" And he said yes, and that's where we are today.
That's cool. Now, when was that?
That was in 2009.
So you've been doing this for a few years now, yeah?
Yes, sir.
Has it gotten any easier?
It's gotten harder.
Yeah?
Yeah. The more models I bring out, the more I sell, the more it requires support. So yeah, it's definitely getting busy. It's getting ready to start hiring employees and growing the company.
That's cool. So right now you've got your setup in the U.S., and then you've got a machine shop in there kitting and doing all that stuff with your N5, N5C, E6, E7, right?
That's correct.
Okay. Now, what does she do? Oh, hold on. We'll ask her. What do you do you work for Synergy, right?
I do.
Botos Design and Distribution. I should be right?
Yeah, that's correct.
And what do you do all day, Amy?
Well, I am in charge of pictures, obviously. Everybody's seen me out there taking pictures. And I'm not choosy. I kind of try and take pictures of everybody and everything. And then I also do the marketing stuff, banners, try and come up with ideas and execute them. And then also I help pack a lot of orders every day.
So when people order stuff, if people have an N5C and they smoke something in and they order from you guys, you put it in the bag, right?
Yes, that's correct. So if you see a long blonde hair, I apologize if it comes in one of your part packages.
Oh, very cool, very cool. All right, cool. Well, like our other quick tips, we did the Goblin, we did the E6-E7. Now it's time to dig into this thing. So we're going to get Matt, we're going to pick his brain. We're going to go into some of your SolidWorks drawings. We're going to take a look at, the model, what his equipment is in here, how it goes together, parts pricing, and everything like that. So it should be pretty good. What do you think?
Yeah, let's do it.
All right, cool. So we'll get into it here, and we're at Birmingham. Beautiful day out. The Synergy E6-E7. Here we go. So I'm here with my good buddy Matt, and he's got his E6-E7 right here. We popped the canopy off, and I gotta say I like it, dude. This is a really simple machine. It's clean. I like the layout. When I hear it, it's quiet. You did a good job, dude.
Thanks, man. I appreciate that.
No problem, no problem. All right, so let's get into this thing. All right, so what's the first thing that sticks out to you of the machine? When you designed this, what was the one thing you wanted?
I wanted simplicity. I don't want people to crash it and not be able to rebuild it. I want very few parts. Parts count's very low. So in the end, it saves the consumer money.
Good, good. So it's called an E6 or E7, so obviously you can fly it as both. Now it comes with a belt, correct?
Correct.
A tail belt. Now does it come with 2 different booms, 2 different belts?
Yes, it comes with 2 different booms, 2 different belts, 2 different boom support lengths, 2 different tail pushrod lengths, so you can run it either way.
Dude, that's sick, man. That's awesome. I didn't know that. That's really, really cool. All right, so now this guy, you got a torque tube on here, right? You just developed it?
Yes.
Okay. All right, we'll get into that in a sec. So let's start anywhere. I think everybody likes to start at the head. So the head, all metal head. If Mr. Cameraman can get in here on the head. Very simple. It didn't look like you tried to redesign the wheel here, but what do you like in the head here?
Well, the arms are absolutely beefy. I mean, you crash this machine, it's very unlikely that you're going to bend these arms. They're secured with an M3x8 in the front, M3x6 in the back. So the arms are not going to come off. There's plenty of thread engagement there. 5mm bolts to secure the blades. Just a nice beefy blade grip, nice beefy head. You got a pinch mechanism here to secure it onto the shaft so you don't get any rocking. And the head is also adjustable so that if you want to change the head height either up or down, you can do that. You can also run this head on almost any other helicopter with a 10mm shaft.
Now, is this the same head? I've got a Synergy N5C. Is this the same head as the N5C?
That is the same exact head, yep.
And great head. It works just fine. Okay, cool. So moving down, I see a swash. Do you assemble this? How's the swash assembled? Is it pretty bulletproof? Can you take out slop?
Yeah, the swash is pre-assembled. There is a set screw in the back here, so you can take out play in the bearing. You've got bearings here that ride in the anti-rotation bracket for precision there. The typical Synergy huge balls here. Your links will never wear out. So it's a great helicopter in that you really have to maintain almost nothing.
I agree. My N5C it reminds me of my Fury. When I built my Fury Extreme, that one took about 2 weeks. Yours only took me about 2 nights. And you build it and you just simply fly it. Now, with your big balls, what do you need?
Well, I'm planning on coming out with some ball link pliers, but right now I use just simply a pair of they're needle nose pliers without the teeth in them, and I simply twist them off. So that works for now.
Do you need any sizing tool, perhaps?
You do need the Botos sizer.
The Botos sizer.
You need the Botos sizer. Okay. I can't take credit for the big balls. That was brought on by Jason Krause, but I like the big balls, so I kept them on the machine.
Dude, I like it. It works well. It works very well. Okay, cool. So coming into here, you got some really funky sort of aluminum mount. I like that it stretches around the motor and stuff. Lots of rigidity here, right?
Well, back to the simplicity thing, I wanted to incorporate servo mounting, frame rigidity, all in one kind of box. And as you can see here, you got a carbon brace.
That goes down, doesn't it?
Yeah, it goes down. It attaches the lower bearing block with the upper bearing block. Okay. So everything is boxed in, so there's absolutely no flex in the frames in that area.
That's sick. Okay, cool. So going on, we've got direct drive servo, which I absolutely love. It's simple, it's nice. So here you got some different servo arms. What do you got going on here?
Yeah, these are carbon fiber servo arms. They attach to the small Futaba wheel, and I think Align does a wheel, and many other JR does a small wheel.
They come with a kit, right?
Yeah, they come with a kit. They bolt directly onto the plastic wheel, and they give you a very precise, rigid feel. No flexing in the servo arms.
Dude, I like that, man. That's nice. That's really nice. Okay, cool. So far, we're heading down here to, let's see, what would you like to look at next?
Well, the third bearing block here is a good feature, and the third bearing block provides that extra rigidity that really the main transmission needs. Without that, you could float around in there, you could potentially tear up main gear. So I incorporated a third bearing block, which is actually adjustable by 1 millimeter each way because it's very difficult to line up 3 bearings in a row doing any type of machine like this. So it is adjustable. That's the last one you would tighten up in the entire process.
Dude, I like that. I like that. All right, cool. Let's move down to the torque tube here. This is your brand new torque tube system, right? Now, you were explaining to me earlier, you still have some different sort of monster gears up front and different gears in the back, or you doing something like that?
Yeah, they're very big gears. They're in the front is a mod 1.25 18-tooth bevel gear. In the back is a mod 1.25 20-tooth bevel gear. So the back is very, very bulletproof. The front's bulletproof as well, but I think the sacrificial portion, if you do hit the tail on the ground, is probably going to be up front.
Dude, that's cool. All right, now one thing that really pops to me, with my dorky engineering mind, I'm looking down here on your, I guess it's your takeoff gear on the main gear. Your disc for the aluminum to support the gear is just as big as the gear. So why'd you make it that big? I'm guessing to reduce the flex in the plastic?
That's it. I mean, the further you have that aluminum out, the more you can support that counter gear, the better mesh you get, the better better durability you have. You're not going to strip that gear.
Okay, I like that. All right, moving down, I see a nice helical cut. Is this a molded or a machine gear?
That is machined Delrin helical cut gear. That is Mod 1. And yeah, it's virtually bulletproof. This gear I've crashed multiple times and still have not stripped it. So I challenge somebody out there to strip that gear. I'm sure it can be done, so I'm not going to say it's absolutely bulletproof, but somebody will probably mesh it wrong, or and it could happen. But
I like that. Now, the one thing people don't realize, they look at crash parts and they say, oh, it's a $45, $50 main gear, but if you set it right, it's never going to break, right?
That's correct. Yep.
Dude, that's cool. Now, one thing about this, I said, I'll say it again. This machine is freaking quiet. When we fly it later, this is probably one of the quietest machines I've ever. In typical Botos fashion, it's smooth and quiet. So, Mr. Hollywood here. All right. So, moving on to the pinion. Do you include different pinions? What kind of gear ratios? Adjustable gear mesh? What do you got going here?
I do. I include a 14 and 15 tooth pinion. Also available as a 12 and 13. The gear mesh is completely adjustable. You've got 5 points on each side for sliding back and forth. So the motor really stays flat when you do adjust it back and forth.
Okay. That's good.
Multiple gear ratios. You can run anything from a, depending on whether you run a 10S or 12S, 450 kV motor up to a 650 kV motor. So very flexible.
That looks good. That looks good. All right, let's head on to the rear end. So I see you got your tail servo mounted back here, just direct mount, nothing special there?
It is kind of special in that you can get the servo out by just removing the bolts on the outside.
Oh, cool.
So you don't have to fish anywhere around. You just remove these 4 bolts. The servo slides in and out. So it's
cool.
It's real easy to get out.
That's cool. That's cool. All right, so you just got normal boom coming back. Boom supports, easy to glue, simple enough. Push rod, you still glue the fronts in and twist the ball link on, right?
Yep.
Okay, cool. Let's move on to the tail here. So we got a big tail rotor here. This is a really, really, really beefy tail rotor in it.
Yes, this tail rotor I wanted to make for today's 3D standards. You got guys out there really pushing the limits, so this is where I came up with the Mod 1.25. This is 20 tooth. This actually is Mod 1.25 20 tooth is bigger than a Mod 1 24 tooth. The base of the gears is huge, so you get a lot more just support out of the gears, a lot more durability. You also have on the side of the tail blocks here, you have 4 mount points here. So basically this thing is not going to swivel, it's not going to twist. 4 mount points to secure it, so there's not any moving in there. Both sides.
That's nice.
Yep, thank you.
That's nice. That's nice. Okay, so 6mm output shaft, like we said, right?
Yep.
What do you got going on grips? 2 radials and a thrust bearing on here?
Yeah, these grips, it's actually a really stout hub. I kept the hub nice and short by using 5x10x3 radial bearings, and then on top of that I have a 5x10x4 thrust bearing, and then another radial on top of there. So you get very little play in the system. There's no bolts breaking off, no hub shearing, anything like that. It's a very rigid system.
Dude, that's nice. And the last thing we missed, I think we missed the torque tube. How's the torque tube work?
Torque tube's just like any other torque tube. It's got bearing couplers with O-rings on the outside of them. They slide on, and then the ends, you red Loctite them in, and then you pin them with a 2mm bolt with a nut on it, and that's it. And
so if you smack it in, you can just replace the tube, can't you?
That's right. You just replace the tube. The ends are still good.
That's awesome. That's awesome. Well, cool, man. Well, thank you very much. So here we had an overview of the machine. I think we pretty much covered everything. So now we're going to go into your electronic setup. Okay, so now that we went over all the mechanics you got going on here, it's time to talk about electronics. So I'm seeing a lot of familiar stuff on here. Great minds think alike. What do you got going on? Walk me through your entire electric setup.
All right, well, let's start with the fly barless control system. We got the CGY 750, nice in the back, nice proven system. Most electronics are located in the back. I find it's easy to wire. Everything stays kind of in a nice little neat section here. Powering or moving the swash, we've got the BLS 255s. Those are HV servos. We've also got the new 18MZ receiver here, which does all the telemetry and everything.
Oh, there you go.
Okay. And powering the entire system, I have a Western Robotics Hercules Super BEC, correct?
Dude, that's the only one we trust, man. That's a good one right there.
Yep.
Good to see you running that, because that's the only one we recommended to everybody out there, and it's good to see the pros using what we like. So that's good.
Yeah. I got the ICE 160 on this one. It's a pretty well proven ESC. Other than that, we got 4,400 milliamp batteries. You can fit, I got one guy on the team running 7S like 5,000 or something like that. So you can fit some pretty enormous packs in this helicopter.
So you could fit like a 10S to 12S 5000s in here?
Yeah. If somebody were creative enough, they could turn this into an 800 size machine and run some really huge packs.
Okay.
Yep.
Cool. So this is your battery slide right in from the front. Battery seems like it's really easy to go in and out. Adjustable for balance and whatnot.
Yeah. The battery, it's a typical Velcro fashion. Slide it in, set it down. I provide the Velcro straps, 3 of them. So you strap the battery down, maybe strap your cables down, make sure they're secure, and that's it. It's very simple.
Okay, cool. Now I see the last thing, your sensor for the gyros down here, right?
Yeah, that's correct. It's actually upside down.
Okay. That's good. So you put it back there to avoid any sort of stuff going on up here?
Yeah, I tried to put it there. It seems like one of the places that would get the least flex in the frames, and it makes sense to put it there.
Now, one thing I hear a lot too, I think you mentioned it as well, your geometry set up for any flybarless control systems, V-bar, B-Stacks, 750?
That's correct. Yep.
So nothing special?
No, nothing special here. You can. I've chosen to lengthen the inner swash balls a little bit to get me a little bit more speed out of the cyclic, but you don't have to do that. The arms are very far out. I believe they're 35 millimeters from center, so it gives you a lot of leverage for your servos to kind of take advantage of.
Okay. All right, cool. Lastly, you got blades going on here. You got your own blades. Tell me about that.
They're the rail blades. So far we got the rail 606, we got the 696. Just released is the rail 326. When I designed these blades, I focused on right down the middle. I wanted a blade that was going to track like it was on rails, obviously because of the name. And I also wanted to maintain that cyclic speed. A lot of times when you get a blade that tracks, you lose cyclic speed. So my goal was to provide a blade that was, that would make everybody happy. So that's what I've basically come up with.
Dude, that's cool. And if the cameraman can see the tip shape is very different. What did you go for there?
The tip shape, it's basically for a quiet operating blade. I believe a quiet operating blade is an efficient blade. If you hear a lot of blades farting out there, it's probably because it's eating up energy. So it's pretty critical to have a quiet blade. I know a lot of people like to do the blade farting and whatnot, but when it comes down to it, you're just using energy. So these are probably one of the quietest blades on the market right now.
Dude, that's sick. All right, cool. Well, we ran through the electronics. We ran through the overview setup. Now, one cool thing about you, we ran through blades, we ran through everything. One cool thing about this, I know you design everything in SolidWorks from the ground up, right?
That's right.
So you input weights, you import everything into the actual computer itself, and then it spits it out. And this looks exactly like what you got on your computer, doesn't it?
That's right. It's when you design in SolidWorks, a prototype really doesn't have to be wrong. The weights are right. Every single thing you see on here is inputted in the correct weights. All the stress analysis with Cosmos, it's all there. So there's really there's no excuse for making multiple prototypes unless you really just ran out of time and screwed up or something like that.
Exactly. Cool. All right, well, let's go into his computer. You got some screenshots for us. Let's go into the SolidWorks drawings and check it out. Okay, so what we got going on here is a machine that you came up with in your mind, right?
That's right.
Now,
right out of this noggin, yep.
So the tool you use, as we mentioned before, was SolidWorks. So walk us through how you started the design of it. Where did you start on the model? Everything like that.
Well, the control system is probably the most important portion of a helicopter design. Once you get the control system down, how you're going to drive the swash plate, where your servos are located, everything kind of falls into place there. So once I'll have my swash plate done, I'll have my servos located, correct geometry and everything right underneath the swash plate. After that, I'll start basically building frames on the side of there. I will basically determine my gear ratio, determine where the motor is going to sit, and it just kind of all flows out from there. After you get the control system done, everything just kind of falls into place.
Dude, that's cool. That's cool. So as you guys are watching, we're looking at some of Matt's SolidWorks stuff. It's pretty cool stuff. I mean, you can move the tail. You can move this back and forth, and your tail pitch slider goes. You can move your swash up and down. Do you use the really fancy features? Do you check your swash deflection in SolidWorks to make sure you're clear here? What kind of stuff do you do in there? The special stuff,
Yeah, absolutely. You have to make sure that when your servo's moving 10 degrees, you get a specific amount of swash travel. Same thing goes all the way up to the head. You move your servo 10 degrees, you get this much travel on the swash, and then you get this much travel on the blade grip. Same thing with the cyclic deflection. You just want to make sure your ratios from the servo all the way up to the head translate well.
That's cool, and SolidWorks is ridiculous. You can spin the motor, set different gear sort of mates, and you can spin the motor and watch your tail gears go just by doing that, right?
Yeah, I mean, essentially, if you had a nice background, you could potentially fly it in SolidWorks because everything's spinning. So just put a background moving around, be pretty cool.
Yeah, exactly. Cool. All right, well, thanks for walking us through the SolidWorks stuff. I thought that's fascinating. That's how we did the Whiplash. That's how all the I know Align uses SolidWorks, so it's very cool to see them do that. So we got this walkthrough, so let's go back inside. We're going to take a look at the manual, and we're going to look at some of the parts pricing. Let's do that. And now we're back from the Birmingham Fun Fly, and Matt gave us that great overview and explanation of everything. And it was hard to fit in a spot for the manual and the prices overview, so I told him I would do it here. So we're back in Florida. Here we go. So he sent me an online version of the manual, which I'm going to show you on the iPad again because it's super easy to do. And it's nice. It's really nice. He said that he's waiting to post it online until he has some more updates and such, but the printed manuals are out there. This manual, it's absolutely beautiful. It's in color. It's about 40 pages long. It's really not that bad. It's really nice. It's really nice. You can see here he's got some very detailed drawings, very detailed views, you know, after discussing SolidWorks, and since he designed it in SolidWorks, it makes it for really nice pictures. You can see everything here is labeled clearly. When I built my N5C, he did it in the same sort of way. There's really beautiful pictures. Everything's laid out nicely, and once again, it's a simple helicopter, so there's not too much to really take a guess on. But there's some really nice stuff in here. I don't think anyone's going to have a problem with any of the manual. You know, you can see he gets detailed and gives the speed controller the proper colors of what he was designing it after. You know, the motor looks like the purple Hacker motor. This looks like the Castle speed controller. You know, just little things that when you build the helicopter, it looks nice. So I imagine that's for download soon on synergyrc.com. You can download that there. But overall, manual gets an A+. He really did a good job on this. I don't know if there's any mistakes or whatnot, but from what I'm seeing here, it looks really nice. So way to go, Matt, on the manual. 40 pages, nothing crazy, straightforward, good. Now it's time for parts pricing. So we'll open up our browser here and take you to experiencerc.com. Stevie and Chris are our buddies, so figured we'd show you their website today. So there's lots of dealers out there. You can order parts wherever you're comfortable. But I'm just sitting here looking at the prices, and they're not too bad. They're really not too bad. Looking here, you can see your main shaft, for instance, is $11. Hard main shaft, that's pretty fair. Looks like tail booms, you can get 2 booms for $22. That's a really nice deal. I think that's pretty good. The Synergy, the N5C, all their stuff is made over in China. Matt designs it here in the US, and it's made over there in China. So luckily they have a very cheap labor over there. But from what I've seen in my N5C kit and on the E6-E7, the machinist knows what he's doing, and they make some high quality stuff. So just because the parts are cheap, it's not a bad thing. I think they get away with a lot over there. They do really a good job over there. Looking at it, landing struts, right here, they're $10, $11 for that. Not bad at all. Boom support's $12 for a set right here. Everything's pretty good from what I'm seeing. But there's only one kicker for this model, and that's, as Matt discussed previously, that's the main gear. I'm looking right here, I'll click on it. The helical main gear, 116 tooth, is $45. It's a CNC machine main gear. It's very smooth, it's very quiet, and as Matt and I discussed, you're really not going to strip it unless you're a total idiot. And sorry, you're not an idiot. Unless you really don't know what you're doing and you set the mesh improperly, or if you really smack it in hard, I imagine you'll strip a main gear. But as a for instance, with miniature, I ran machine main gears for years and years, and I think I stripped one. So I think that one's going to hold up. And if it were me, I'd rather pay $45 for a gear that I know is not going to strip than to buy the $6 plastic molded crappy gears from certain companies that tend to strip, and then you need to buy an upgrade anyway. So with this model and their stuff, it looks like you don't need to buy any upgrades. So the kit's in the mid $700 range. I forget exactly where it is. Parts seem completely comparable to everything we're seeing there, to Align, to Gaui, as we mentioned last month, to Outrage, to even the SAB Goblin. Everything seems to be around the same price now, which is nice. It's a very nice helicopter. He makes very good parts. So for the manual and the parts pricing, I think they're right on. So let's move on. All right, guys, we're back out here at the field. Matt has graciously decided to give us a little bit of the demo flight to show us the E6-E7. So Matt, you got the, this is set up as an E7, right?
That's correct, E7 with a torque tube.
E7 with torque tube. All right, so first thing I'm hearing, it's quiet, dude.
Very quiet, almost silent. It's just purring there.
Cool. All right, crank it up. What kind of head speed are you running here?
That is 2,000.
2,000 on the head. What kind of a flight time?
With this setup, I'll probably get 4.5 minutes. Very, very aggressive collective. Very poppy. Very powerful. It's a light helicopter. You can configure this helicopter for, anywhere from 10 1/4 to, probably 10 3/4, depending on which batteries you use.
Now, the biggest thing I see with this, it's just smooth. There's no shakes, there's no nothing. Now, electrics generally are smooth, but this thing, do you do any sort of tweaking? Do you dial indicate stuff?
No, out of the box, you don't really have to do anything. Now, if I have a crash, of course, I'm going to go back through everything and dial indicate, but, it should be this smooth right out of the box with no tweaking.
Nice. All right, give me some big air stuff, man. I know there's a lot of people here. Let me see some big stuff here. Track's good through forward flight and everything?
Oh, yeah, beautifully. It's on rails, just like they're... Just like the advertising, this helicopter flies like it's a freight train. Not on weight, but just the way it flies and tracks through the air.
It looks good, man. It looks nice and nimble. I don't hear anything crazy out of it. It looks good.
Oh, yeah. It's just a pleasure to fly.
All right, I highly suggest you guys check out videos. I know you're flying it. I know Kyle Stacy's flying it. A bunch of your reps are flying them. So, guys out there, take a look at the YouTube, Synergy E7 and whatnot.
Definitely. Check it out. SynergyRCHelicopters.com. You can come to the forum for tech support, which is SynergyRCHelicopters.com/forum. You need any help, those guys on the forum are absolutely awesome.
Very cool, very cool. Now, very last, I guess I forgot to ask you, how does the belt fly on this compared to the torque tube?
Well, I think the belt does not fly as good as the torque tube. You definitely get a little bit more tail precision, as you can see. I mean, you can just literally beat the hell out of the tail. It's not going to fail on you. The belt, it'll stretch a little bit. It's not as good as a torque tube. On the 600 size, it's a little different story. 600 size, there's definitely not as much stress on it, so you may not notice as much of a difference. So if you're going to fly the E7, I highly recommend the torque tube.
So guys out there, what if they're just doing sport flying with the E7? Is that okay?
Oh, sport flying with the belt, no problem.
Extreme 3D, we want a torque tube one here. All right, cool. So I imagine this thing auto is great with no drag and whatnot.
No doubt. And you get a little pop at the end. And boom.
Cool. All right. Well, thank you so much, Matt, for walking us through everything. It was a pleasure. Synergy E6-E7. Check it out, everybody. I'm really fascinated. Where can guys get these? What do you got going on overseas in the world? What do you got going on?
We'll climb out to distributor over in the UK. In the US, I distribute. You got Experience RC, Ron Lund, A-Main Hobbies, Heli Direct, any of the major hobby shops. Esprit Models down in Florida. I'm averaging probably 1 or 2 dealers, new dealers per month. So they're coming on. They're really picking up the model.
Very cool. Overseas. So you mentioned Europe. How about Asia, Australia, that market?
Australia, we have Extreme Helis out there distributing. There's a few hobby shops. In Asia, I'm holding back on that market right now. I do have some in Singapore and some in Thailand. In China, that'll probably be available in maybe the end of the year.
Very cool. Lastly, price.
Price $775 is the retail on this kit. I do not have a price point on the torque tube. I should have that maybe in the next couple weeks, but I promise I'll try to make it affordable for you.
Cool. Matt, pleasure as always. Thank you so much. E6-E7, check it out, everybody. Thank you for watching. We will see you next time on Quick Tips number 5. God knows what it'll be. No, thank you. It's running? It's the friggin' thing on! Okay. This is the electronics walkthrough, take one.